Okay, so next presentation will be given by an inverter manufacturer, which is obviously also a very important part in the solar power plant equation. And we're happy to have with us Greg Lukens, who's the Utility Director Europe at Solis, and he will talk about string inverters and power plants. Gregory, the floor is yours.
Thank you very much, Michael. Yes, indeed, I will talk about string inverters. So thanks very much. I'll go ahead and share my screen. One moment as I complete this. Very good. So you're seeing my screen, correct? Perfect. Thank you. Thank you for the opportunity to speak today. It's a pleasure. And a big welcome from Madrid to everyone. My name is Gregory Lukens. I've been working in solar now, based here in Madrid for 20 years. So it's been quite some time. I've been around quite literally the world in this career. Prior to working in solar, back a long time ago, back in the 90s, I was in Los Angeles in California. I was working in communications industries, as well as software development. So I was, really part of the initial wave of digitalization when the internet was launched and all of these kinds of things. So I have a background in these kinds of innovative technologies and understand fully the power of digitalization and these aspects that are so important to us as we evolve the sector still today. So I've been working now with Solis for about a year. I joined exactly a year ago, basically, and I've joined as the Utility Director for Europe. So I'm in charge of leading a new initiative for an established company here in Europe for utility scale. So this is what I will talk to you about this morning. So first of all, I'll talk quickly about the company. The brand is Solis. This is how we brand our inverters in the world, mostly outside of China. But the company behind this is called Ginlong Technologies. Ginlong has been in existence for approximately 20 years. We'll go to the next slide. It started in 2005, so 19 years. And I won't go through all these details, but just to point out a few big points. Shortly after the company was founded, the company immediately looked towards Europe. The founder of Ginlong is a gentleman named Wang Yiming, otherwise known as Jimmy in the sector. Perhaps some of you have met him in the past. And he studied in the UK. So in the UK, we're quite strong in Europe, and have been operating, as you can see, since 2006. So as time has moved on, the company continued to grow and has been recognized as a top brand. And in the last couple of years, it's been ranked number 3 in inverter manufacturing, behind the big two, which I guess are Huawei and Sungrow. That said, we've also been recognized by EUPD with regard to top brands in the PV industry. I'd also like to point out this photograph we're seeing here is a photograph of our campus. We're in the Zhejiang province, so we're quite near Ningbo, which is one of the largest ports in the world, and it's the principal port that we're using to export our inverters to the world. I'll move on. So approximately 4,500 employees with about 800 dedicated to R&D. Today we have an 80 gigawatt capacity, which is quite remarkable. It's a tremendous amount of inverters. Again, we make string inverters, no central inverters here, all string inverters, and we make inverters as small as 500 watts, for the balcony type installations, which are coming into the market today. And in the next year, that will be expanded to 120 gigawatts. So a really massive amount of capacity. And we see on the right here a photograph of our factory. This factory, I showed the photograph of the campus. The factories are located there. So everything is really co-located into one campus facility. We do have offices in other parts of China, but the principal activity is happening there. And what we see here are some state-of-the-art manufacturing techniques. These factories, the first one came online about a year and a half ago, and the second one about November, December of last year. And as I mentioned, the third one's coming online later this year. So the factory is highly automated. 5G communication technologies are employed. We're using artificial intelligence with high resolution cameras in order to detect errors during the manufacturing process. So quality is a tremendous is of tremendous importance here. What I'd also like to mention, which I think is quite important, is the company's focus is fully on string inverters. We're not manufacturing electric chargers. We're not manufacturing batteries. It's true, we are manufacturing PCSs for the integration into solutions, but the company is really focused on one thing, and that's string inverters. Of course, that translates to expertise, quality, and know-how. So with that, I'll move on to the next point. The point here is that we really have based the business on a very solid supply chain with regard to the components. I won't go through a lot of this, but I will mention one thing, which is the IGBT. Of course, the IGBT is the beating heart of the inverter, the CPU, if you will, of the inverter. And we are using Infineon, which is Germany's leading semiconductor manufacturer, for all of the inverters that we're selling outside of China. So this is a point because not all manufacturers are using such high quality components, or some of them may be using new components which which don't have the track record in the field, perhaps that we have, or that Infineon has in the sector. So we take seriously some of the points that were raised in the earlier presentation about supply chain transparency, supply chain management. As I mentioned, our component selection is something that we really take quite seriously, and we manage our supply chain accordingly. Of course, our product design, we are in contact with customers, those being EPCs or developers, IPPs, in order to really understand what their needs are and design an inverter solution which really meets their needs. We are working to make sure that our own energy consumption, which translates to the next point, our carbon footprint, is as low as possible. So we're constantly making improvements in this regard. So now I'd like to talk to you a little bit about our solution. So the solution is based on a string inverter topology. And, I've been around long enough to know that and to have experienced what was the previous logic in utility scale plants, which was big project, big plant means big inverter. So this was the time of the central inverters back 10 years ago. I'm in Spain, and in Spain, this is the Europe's leading utility market. It has been for some time now and continues to be a tremendous amount of development here. But it also is a country which has its own local manufacturers, but those manufacturers have been dedicated to central inverter topologies. And in the last 6 years or so, through events or through the activities of some of our competition, there was really a change in the marketplace with regard to the logic around topology. So really from a centralized to a decentralized topology. I look at this in the computation days. There was the mainframe, and then came along client server. So, with the mainframe, you had a specialized room with a lot of specialized equipment. You needed specialized technicians, maybe some spare parts over there. If something went down, the whole thing went down. So it became a real bottleneck. And there's a lot of other issues with that kind of computational configuration, which is therefore why the next evolution came, which was client server topology, which was to distribute the computing function into different places. Therefore, you get robustness and reliability, as well as performance benefits. So this kind of thinking is a little bit similar to what we think about with a utility scale plant, and this revolution of decentralized inverter topology. So our inverters will be distributed around the field with the panels, and then they're organized into blocks, typically around what we see here, a mid-voltage station, which accepts the energy from a number of inverters, up steps the voltage to what it needs to be, and then out to the grid. Really, the third piece of this and the third component of this little puzzle for utility scale would be then the data equipment. So the data equipment means typically, and in our case, a data logger, and that data logger is usually located with the mid-voltage station, and its role is to read and control the inverters ultimately up and down, bidirectional. And the data logger itself typically then at the plant level is connected to a power plant controller, and that power plant controller is located near the connection point, and as its name indicates, it's really the brain of the plant, and it's addressable by the TSO, by the grid operator, so that the grid operator can manage the plant in real time. And of course, this requires, at the end of the day, what this is all about is about grid code compliance. So, and controllability of the inverters within the ever decreasing loop times, which are happening. And of course, grid code is something 10 years ago, 15 years ago, really no one really talked about. But of course, with the integration of more and more intermittent renewables onto the grid, then the necessity for the grid to become computational is really necessary. So I won't really go into details here. Today we have, in 2024, this is really our battle horse here. This is our utility scale inverter. It's a 255 kilowatt inverter. Of course, 800 volt AC output, which is really the standard for utility scale inverters. And this inverter is available today. The next inverter that we're launching right now is our 350K inverter. This inverter will be available for delivery in Europe in Q1 2025 next year. So right now we're undergoing our first deployment of this inverter. Is about 200 or 300 megawatts underway in China, where we're, let's say, debugging or making sure everything is okay in China before we launch this inverter to the rest of the world. In the meantime, we are undergoing all the certifications for each country in Europe. this means that we will have two inverters available, a 255K inverter and a 350K inverter. And a quick point about this is a lot of the feedback that I've gotten from the marketplace, and it's not uniform, and it really depends, I think, on the customer, on the project, of course, is that in Europe, of course, we have more complicated layouts. If we were in Arizona or in the Atacama Desert, maybe you have a nice flat rectangle in the desert, and there's no issues to deal with, such as typical things that may happen in Europe, like a very complex layout with distributed plots of land that need to be connected, or you've got a river or a creek or trees or lines or a road or something. So many customers have told us that they prefer a 250 kilowatt machine because it's a bit more modular than a 350 kilowatt machine. But that's okay. We provide technical support to help customers optimize their design and choose the best equipment. Next is a mid-voltage station. What we're showing here is a 6 megawatt version. We also have a 3 megawatt version. In this particular case, this station is manufactured in China by a tier 1 manufacturer. But we're also open. If a customer would like this particular transformer station, we're happy to provide that. But we also are working with local European integrators, and we're already doing that in Germany, for example. So we can do both ways. We can work with European integrated mid-voltage stations or with ours that are imported from China. We also, of course, have after-sales service, which involves let's call it a triage line, a call center. So we can help the customer on site to determine what's going on with the inverter. And if there is a problem with the utility scale inverter, there is a small stock available on site at the project so that the inverter can be swapped. And if it's under warranty, we will send a new inverter in. So I'm trying to go quickly here because I know we're a bit short of time. We're operating really worldwide, from Europe to the Americas, in Asia, South Africa, Australia, and in each country we have service centers to provide post-sale service. And so my last slide, just to say, as I mentioned, we manufacture every inverter that we sell, which provides a benefit of traceability and robustness. The manufacturing facilities we have are state-of-the-art, which translates to reliability. Sourcing worldwide our components generates confidence. Exclusively focused on string inverters means expertise. With regard to the data equipment, I don't think I mentioned this, but this is an important aspect. But we are working with European data equipment providers, which provides assurance of cybersecurity compliance, which I think in all of Europe is a concern today. In some countries, perhaps more than others, but we believe that this trend will continue. So we really want to assure to our customers that their data is being cared for as they wish it would be cared for within Europe. Our mid-voltage approach provides flexibility. And lastly, we're competitively priced. So we can provide lower LCOE and ultimately a higher RRR for the project investor. So we are a robust alternative in the European market for string inverter topologies. So with that, I think I've hit my time. Thank you.
Thanks, Greg. Great overview. Just one quick question, or maybe two on supply. So I think last year there was this issue while there was huge oversupply and a lot of product in warehouses on the smaller side of string inverters. I think the bigger ones were on short supply actually last year. So how has that changed actually over the course of this year for the bigger string inverters? And second is what's still big where's this big lack is transformer stations in Europe. So how easy is it to get and how quickly can transformer stations be delivered by you for power plants?
So the first question, that you're right, exactly. Last year we had few inverters to sell. In Europe, we were able to generate about 80 megawatts in Poland and about 20 megawatts in Sweden. But that was about it. We didn't have a supply. So there was indeed this shortage. We made our pilgrimage, if you will, to Infineon in Germany back in September. But all of this problem has been resolved. Infineon had a massive reinvestment campaign underway, which took its time to take place after the pandemic. So, and there's other factors involved there. But here, as we sit today talking, there's no issue whatsoever with IGBTs for this class of inverters, for 250 or 350. With regard to mid-voltage stations, our own lead times from the PO is approximately, I would say, something like 18 to 22 weeks. So that means from PO to delivery in Europe. And with regard to European integrated stations, it really varies, because it is a dynamic market. The transformers, as you mentioned, are the real bottleneck. But there are a number of leading integrators here that have very good supply. They work with different suppliers, so they do have some, let's say, flexibility in their own component supply chain. I can't tell you today exactly what their lead time is today. This afternoon I'll be with an integrator, so perhaps later today I could tell you directly, but at this moment I can't say. But there is some lead times for as much as a year, perhaps last year or something. But I don't think that this is the case anymore. It's somewhat less. Perhaps it's in the 20 to 25 weeks. But again, this is a bit of speculation based on my knowledge from a month ago. But it is a dynamic situation. But and it's something I think that needs to be seen case by case, right? Depending on the requirements, depending on the market, depending on the quantity, etc.
Okay, perfect. Thanks. I think we will discuss it also with the developers later on. Thanks again for this great summary. And
Sure. You're welcome. Pleasure. Thank you.